Article 620.51 of the National Electrical Code, or NEC, addresses the control and machine room disconnecting means for elevators. It's crucial to understand what this article covers to ensure safe and compliant electrical installations for elevators. The primary focus of Article 620.51 is not to limit the number of disconnects for a single elevator in the machine room. Instead, it specifies the requirements for the disconnecting means that must be provided. Let's break down the key aspects of this article to clarify its intent and application. Firstly, the purpose of the disconnecting means is to remove all power from the elevator equipment for maintenance, repair, or emergency situations. This is a fundamental safety requirement to protect personnel working on or around the elevator system. Secondly, the location of the disconnecting means is critical. Article 620.51 typically requires the disconnect to be readily accessible and located in the elevator machine room. This allows authorized personnel to quickly and safely de-energize the elevator equipment when needed. Thirdly, the number of disconnects is determined by the specific configuration and electrical design of the elevator system. It is not uncommon to have multiple disconnects for a single elevator, especially in more complex installations. These disconnects may serve different purposes, such as isolating the main power feed, control circuits, or lighting circuits. Fourthly, each disconnecting means must be appropriately sized and rated for the intended load. This ensures that the disconnect can safely interrupt the flow of current without causing damage to the equipment or creating a hazard. Fifthly, the disconnecting means must be clearly labeled to indicate the equipment it controls. This helps to prevent confusion and ensures that the correct disconnect is used in an emergency. Sixthly, some elevator systems may require additional disconnecting means, such as those for shunt trip breakers or emergency power systems. These disconnects must also comply with the applicable requirements of Article 620.51. Seventhly, it is important to note that the NEC is a minimum standard, and local jurisdictions may have additional requirements for elevator electrical installations. It is always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Eighthly, when working with elevator electrical systems, it is essential to follow all safety precautions and use appropriate personal protective equipment. Elevators can be dangerous, and it is crucial to de-energize the equipment before performing any maintenance or repair work. Ninthly, regular inspections and maintenance of elevator electrical systems are essential to ensure their continued safe and reliable operation. This includes checking the condition of the disconnecting means, wiring, and other components. Tenthly, if you have any questions or concerns about the application of Article 620.51, it is always best to consult with a qualified electrical professional. They can provide expert guidance and ensure that your elevator electrical installation is safe and compliant. In summary, Article 620.51 does not limit the number of disconnects for a single elevator in the machine room. Instead, it specifies the requirements for the disconnecting means that must be provided to ensure safe and reliable operation of the elevator system. Understanding these requirements is essential for anyone involved in the design, installation, or maintenance of elevators. Now let's delve a bit deeper into some of the specific requirements related to elevator disconnects. It's important to remember that electrical codes are constantly evolving and interpretations can vary. Consulting the latest edition of the NEC and seeking guidance from local authorities is always recommended. Firstly, let's consider the disconnect's accessibility. The code emphasizes the need for disconnects to be readily accessible to qualified personnel. This means they should not be obstructed or require the use of tools to access, unless specifically permitted by the code. This accessibility ensures that in an emergency or during maintenance the power can be quickly and safely shut off. Secondly, the labeling requirements are crucial for safety. Each disconnect must be clearly and permanently labeled to identify the specific elevator equipment it controls. This labeling prevents confusion and ensures that the correct disconnect is used when needed. The labeling should be durable and easy to read even in low light conditions. Thirdly, the type of disconnect switch is also important. The disconnect switch must be horsepower rated if it's used to disconnect a motor load. This rating ensures that the switch can safely interrupt the motor's starting current, which is significantly higher than its running current. Using the wrong type of switch can lead to premature failure and potentially dangerous situations. Fourthly, the location of the disconnect is often dictated by the specific layout of the elevator machine room. However, the code generally requires the disconnect to be located within sight of the elevator controller. This allows the person operating the disconnect to visually confirm that the correct equipment is being de-energized. Fifthly, in some cases, multiple disconnects may be required for different components of the elevator system. For example, there might be separate disconnects for the elevator motor, the lighting system, and the control circuits. This allows for selective isolation of different parts of the system for maintenance or troubleshooting. Sixthly, the disconnecting means must be lockable in the open position. This is a critical safety feature that prevents the disconnect from being accidentally re-energized while someone is working on the elevator equipment. Lockout/tagout procedures should always be followed when working on electrical equipment. Seventhly, the NEC also addresses the requirements for disconnecting means for elevator hoistway equipment. These disconnects must be readily accessible and located in a safe location, such as outside the hoistway door. Eighthly, it's important to consider the voltage and amperage ratings of the disconnect switch. The switch must be rated for the maximum voltage and current that it will be required to interrupt. Using a switch that is not properly rated can lead to overheating, arcing, and potentially a fire. Ninthly, the code also addresses the requirements for disconnecting means for elevator machine room ventilation and air conditioning equipment. These disconnects must be readily accessible and located in a safe location. Tenthly, it's important to stay up to date with the latest changes to the NEC. The code is updated every 3 years, and there may be significant changes that affect elevator electrical installations. Consulting with a qualified electrical inspector or engineer is always recommended to ensure compliance with the latest requirements. Let's further clarify common misunderstandings about Article 620.51. A frequent point of confusion revolves around the interpretation of single elevator. While Article 620.51 doesn't restrict the quantity of disconnects for a singular elevator, it mandates that each disconnect is installed according to code, properly labeled, and readily accessible. The NEC emphasis is on safety and the ability to de-energize equipment quickly, not on arbitrarily limiting the number of disconnects. Another misconception is that a single main disconnect covers all electrical components of an elevator. Often, elevators have supplementary systems like lighting, ventilation, or communication that necessitate their own dedicated disconnects. This ensures that each system can be independently isolated for maintenance without affecting the entire elevator operation. Another thing to consider is emergency conditions. Disconnects play a critical role in emergency situations such as fires or flooding. Properly placed and labeled disconnects allow first responders or trained personnel to quickly cut power to the elevator, preventing further damage or hazards. The accessibility of disconnects is paramount in these scenarios, as every second counts. Furthermore, the type of elevator system affects the number and placement of disconnects. Traction elevators, hydraulic elevators, and machine room-less or MRL elevators have different electrical configurations. Each type may require a unique arrangement of disconnects to ensure complete electrical isolation during maintenance or emergencies. For instance, MRL elevators, where the machine is located within the hoistway, might have specific requirements for hoistway disconnects that differ from traditional machine room elevators. It's also important to consider the interaction between Article 620.51 and other relevant articles in the NEC. Article 700, for example, addresses emergency systems and standby power. If the elevator is connected to an emergency power source, the disconnect arrangement must account for this, ensuring that the emergency power can also be safely disconnected when necessary. Proper coordination between these different articles is crucial for a safe and compliant installation. Additionally, the NEC provides guidelines on the proper wiring methods for elevator circuits. These wiring methods are designed to minimize the risk of electrical faults and ensure the reliability of the elevator system. Using the correct type of wire, conduit, and connectors is essential for a safe and long-lasting installation. Now consider best practices when working with elevator disconnects. Firstly, always verify that the correct disconnect is being used before de-energizing any equipment. Double-check the labeling and ensure that it corresponds to the equipment you intend to work on. Secondly, use a reliable voltage tester to confirm that the power has been completely shut off before touching any electrical components. Never assume that the power is off just because the disconnect is in the open position. Thirdly, follow proper lockout/tagout procedures to prevent the disconnect from being accidentally re-energized while you are working on the equipment. This is a critical safety step that can prevent serious injury or death. Fourthly, inspect the disconnect switch for any signs of damage or wear. If the switch is damaged, it should be replaced immediately. Fifthly, keep the area around the disconnect switch clean and free of obstructions. This will ensure that the disconnect can be easily accessed in an emergency. Furthermore, ongoing maintenance of elevator disconnects is crucial. Regularly inspect the disconnects for corrosion, loose connections, and any signs of overheating. Tighten any loose connections and replace any damaged components immediately. This will help to ensure the reliability of the elevator system and prevent potential hazards. Also, proper training for personnel who work on elevator equipment is essential. Make sure that all technicians are properly trained on the safe operation and maintenance of elevator disconnects. This training should include lockout/tagout procedures, proper use of test equipment, and recognition of potential hazards. In addition to the NEC, other standards and regulations may apply to elevator electrical installations. These may include local building codes, ASME standards, and OSHA regulations. It's important to be familiar with all applicable requirements and to ensure that the elevator installation complies with all of them. Remember, the goal of Article 620.51 is to provide a safe and reliable means of disconnecting power to elevator equipment. By understanding the requirements of this article and following best practices, you can help to prevent electrical accidents and ensure the safety of elevator technicians and passengers. Let's consider some specific examples to illustrate the application of Article 620.51. Imagine a scenario where an elevator has a separate motor controller for the main drive motor and another controller for the door operator. In this case, it would be necessary to have separate disconnects for each controller. This allows for selective isolation of the motor drive or the door operator for maintenance or troubleshooting. Another example would be an elevator that is equipped with a regenerative drive system. This type of drive system can generate power back into the electrical grid under certain conditions. In this case, the disconnect arrangement must be designed to safely interrupt the regenerative power flow. Yet another example would be an elevator that is located in a hazardous location such as a chemical plant. In this case, the disconnects must be rated for use in hazardous locations and must be installed in accordance with the applicable requirements of the NEC. These are just a few examples of how the requirements of Article 620.51 can vary depending on the specific elevator system and its application. It's important to carefully consider all of the factors involved and to consult with a qualified electrical professional to ensure compliance with all applicable codes and regulations. Let's delve into the specific wording of Article 620.51 to better understand its requirements. The article typically begins by stating the general requirement for a disconnecting means to be provided for elevator equipment. It then goes on to specify the location, accessibility, and other characteristics of the disconnecting means. The wording of the article is often very precise and technical, so it's important to read it carefully and to understand the meaning of each word. For example, the article may use the term readily accessible, which has a specific definition in the NEC. It's important to understand this definition to ensure that the disconnect is installed in a compliant location. Another example would be the requirement for the disconnect to be lockable in the open position. This requirement is intended to prevent the disconnect from being accidentally re-energized while someone is working on the equipment. The specific wording of Article 620.51 may vary depending on the edition of the NEC that is being used. It's important to consult the latest edition of the NEC and to be aware of any changes that have been made. In addition to the specific wording of Article 620.51, it's also important to consider the intent behind the requirements. The intent of the article is to provide a safe and reliable means of disconnecting power to elevator equipment for maintenance, repair, or emergency situations. By understanding the intent of the article, you can better apply its requirements in a practical and effective way. Let's also consider the role of the electrical inspector in ensuring compliance with Article 620.51. The electrical inspector is responsible for reviewing the elevator electrical installation and verifying that it complies with all applicable codes and regulations. The inspector will typically examine the disconnects to ensure that they are properly sized, located, and labeled. The inspector may also perform tests to verify that the disconnects are functioning properly. It's important to cooperate with the electrical inspector and to address any concerns that they may have. The inspector's goal is to ensure the safety of the elevator installation, and their expertise can be invaluable in identifying potential problems. Remember that compliance with Article 620.51 is not just a matter of following the rules. It's about ensuring the safety of elevator technicians and passengers. By understanding the requirements of this article and following best practices, you can help to prevent electrical accidents and create a safer environment for everyone. Let's consider some common violations of Article 620.51 that electrical inspectors often encounter. One common violation is the failure to provide a disconnecting means for elevator equipment. This is a serious violation that can create a significant safety hazard. Another common violation is the installation of disconnects in inaccessible locations. This makes it difficult to energize the equipment in an emergency. Another violation is the failure to properly label the disconnects. This can lead to confusion and delays in an emergency. Yet another violation is the use of disconnects that are not properly sized for the intended load. This can lead to overheating and failure of the disconnects. These are just a few examples of the common violations of Article 620.51 that electrical inspectors often encounter. It's important to be aware of these violations and to take steps to avoid them. Finally, let's consider the importance of ongoing training and education for elevator technicians. Elevator technology is constantly evolving, and it's important for technicians to stay up to date with the latest changes. This includes training on the latest requirements of the NEC and other applicable standards and regulations. Ongoing training and education can help technicians to perform their job safely and effectively and to provide the best possible service to their customers. It can also help them to avoid common violations of Article 620.51 and other electrical codes. In conclusion, while Article 620.51 doesn't limit the number of disconnects, understanding and adhering to its guidelines is paramount for elevator safety.